So composite functions are functions in which we either combining them or we're plugging one into the other. Okay, so you'll see notations like this: f plus g of x, f minus g of x, f times g of x, f over g of x, and then f open dot g of x. Okay, and most of them are pretty straightforward. If it says plus, then we are taking and we are adding the two functions. So we can either add, let's say they are expressions, we can add the expressions together and then combine like terms. If it's a minus, then you're subtracting the second from the first and combining like terms. If it's next to each other, flush, then that means it's being multiplied together. We literally would just multiply the two functions. If it's one over the other, then we're dividing, and obviously order matters here. This second part says g of x cannot equal 0 because whatever's in the bottom can't be 0. It would be undefined. That could be like a domain restriction, okay? And then comes your combined functions. So f open dot g means we take g and we plug it into the x on f. So this is read as f of g, and we go innermost out. If it had switched and it said g of f of x, oops, if it said like this, g of f of x, now we're taking the f and we're plugging it into the g. So we always go right to left on these, okay, or innermost parentheses out. But open dot is not the same as multiplying. All right, so in example 1, it says find a f of g of x, b g of f of x, and the domain. So we're going to start with the finding, and then we'll talk about what it means when we get to domain. So a is f of g of x, which means I'm taking the g function, and I'm plugging it into the f of x function. So in place of that x now goes x squared. If I could combine like terms, I would. If I could simplify it, I would. If not, you leave it exactly as it is. With me so far? Okay, b is the other way around. B is find g of f of x. So this time we take the f of x and we plug it in place of the x and the g. So this becomes 2 plus 1 squared. If it's an open-ended question, it's totally fine to leave it as it is. If it's multiple choice, you might see it expanded, okay? So to review the shortcut on a perfect square, or the square of a binomial, we square the first term, so it'd be 4x squared. We square the last term, so it'd be plus 1. And we double the product, so it'd be plus 4x. So if it's multiple choice, and obviously it's written like this, we need to know how to get there. If it's open-ended, either of those would be fine. Are we good so far? Okay, so here's the so listen to me carefully, because here's the complicated process of the domain of a composite function. If it is adding, subtracting, or multiplying or dividing two functions, okay, then if either of the original functions have a domain restriction from the beginning, it gets carried down, and we check the new one to see if there's an additional one. With composite functions, you're only carrying down the function on the right-hand side of your statement. So when I have f of g of x, I have to look at the original g of x and ask, is there a domain restriction? If there is, we carry it down. If there's an original domain restriction on f of x, I don't even look for it because that's the one on the outside, okay? So I look on the one on the inside. Is there a domain restriction? If there is, I carry it down. Then I look at my answer and ask it again, is there a new restriction? If there's both, I combine them, okay? If there's neither, then it's all real numbers, okay, that kind of thing. So on A, I am first looking at g of x. Does g of x, x squared, have a domain restriction? What am I looking for when I say domain restriction? Variable under square root, variable in the denominator, or the combination of the two, right? Neither of those things are happening. So there's no domain restriction on g of x. You with me on that? Then I carry down and I look at my answer at the end. Is there any domain restriction on 2x squared plus 1? No. So the domain of this function is all real numbers or negative infinity to positive infinity. Now on B, which parent one am I looking for to carry down? F of x. Is there a domain restriction on f of x? No. Is there a domain restriction on my new function? No. So my domain is also all real numbers or negative infinity to positive infinity. Look at example 2. A, f of g, b, g of f, and then find the domain. So I'm going to do A. Which one gets plugged into which one? G is going into the f of x. So this becomes 1 over x plus 3. Which one am I checking the original for its domain restriction? The G. Is there a domain restriction on G? No. Now I look at my new function, my combined function. Is there a domain restriction? Yeah, what is it?
X can't be 3.
Good. X can be, well, -3. But so negative infinity to -3, union -3 to positive infinity. Then I go to B. F is getting plugged into G now. So F gets plugged into G. So it becomes 1 over x plus 3. Totally an acceptable answer, but you also might see a multiple choice, then find a least common denominator and combine this into 1. So this would be 3 over x, right? And then it would be 1 plus 3x over x is how it would change. So just know that it could be written that way. Is there a domain restriction in my initial f? Right, because we're doing the one on the right. Is there a domain restriction in f? Yes. What is it? X cannot equal 0. Then I check my new one. Is there a domain restriction in the new one? Yes, but it's the same, right? It still can't equal 0. So my domain is negative infinity to 0 and 0 to positive infinity. Now let's say when I had made my composite function, this now said something like 1 over x plus 1 plus 3. Now I've got my can equal 0 from the beginning, and now it can equal -1 as well. Does that make sense? Okay. Questions on these? Okay, second and third way we're going to see this is a combination. These are really common types of questions for FRQs. They'll give you an f of x that is either an equation, and a g of x that is a graph, and an h of x that is a table, and it's going to make you pick from each. This time I only have two. I've got an f of x, which is the graph, and I've got a g of x, which is the table. But they could throw in an equation, okay, and you can all have to like literally pick between those three. So this is when you really got to pay attention to the letters. So A says find f of g of 2. So use order of operations, right? This is easy. Start at the inside one. So the g of 2, which one am I using, the graph or the chart? The chart. What is g of 2? 2, right? Because the input is 2, the output is 2. So then I want to find f of 2. Now I'm using the graph, right? What is f of 2? 0. Yeah?
Yes.
Okay. All right, go to B. G of f of 2. Well, what's f of 2? 0. What's g of 0? 4. So it's not a two-part answer. It's just the last answer. And then C, and careful with your parentheses here. It says find f of g of 0 minus f of 3. So I'm going to find g of 0. What's g of 0? 4. I'm going to find f of 3. What's f of 3? 2. I'm going to do 4 minus 3, which is 2. And then I'm going to find f of 2, which is 0. Yep.
How'd you get g of 0 plus 4?
Because this is g, right? This is g, the input, output.
Well, where's 0? It says
F of 2 is here. F of 2 is 0.
Oh, you took it from the graph.
Yeah, you got it. You're combining the two. We still good? All right, example 4 says given f of x equals x squared minus 4 and the graph of g of x, find 2 of f of g of x when x is 2. So now I'm sorry, when x is 1. So now I'm taking that 1, I'm putting it in the place of the x. So this is 2 f of g of 1. Start innermost parentheses first. Notice that this is my g of x. It says it here. The graph is the g of x, and the f of x is the equation. So if I want to find g of 1, I'm going to my graph. What is g of 1? Negative 2. So g of 1 becomes negative 2, and then I want to find f of negative 2. So I use the equation, right? Negative 2 squared minus 4 would be 4 minus 4, which is 0. And I get 2 times 0, which is 0. Questions? Yeah.
How would we answer? We just put 0.
Just 0. Yep. All right. Example 5. It says, given h of x equals f of g of x, decompose h of x by identifying a valid f and g. So now we're basically saying what two functions put together where g gets plugged into f is going to give me h at the end, okay? The easiest way for, there are more than one answer for these, but I think the easiest way to do it is look for your operator. Like, am I squaring something? Am I square rooting something? Is it in absolute value? Whatever it is. And make that the one you're plugging into. So if I look at A, this is being raised to the second power, right? So if I made my parent function an x squared, then whatever I plug into the x squared would be the one on the right, the g, and the f would be the x squared. So what's the operation we're doing? We're squaring. I'm going to make that my f of x. And then what are you squaring? What's the input that you're squaring? What's inside the parentheses? 2x plus 1. I'm going to make that my g of x. And then I'm going to literally say, if I take g of x and I plug it into f of x, does it give me h of x? Yes, right? Yeah.
But how are you turning the h of x into a?
You're breaking, what do you mean to a?
Into the equation that a gives you for
That
h
is h of x. So you're saying what two functions, when one is plugged into the other, results in that?
And how do we figure that out?
For me, the trick is figure out what's your parent function. Is you squaring? Are you square rooting? Are you whatever that is, right? Make that the one on the left, the thing you're plugging into, so the f of x this time. And make what it is you're plugging in the thing on the right, which is the g of x this time. So look at B. What would be that parent function? 1 over x. So if I make f of x 1 over x, what would I be plugging into that x to get that h of x out? X minus 2. So then g of x is x minus 2. Questions? Yeah.
Why x minus 2 and not 2?
Because if I replace x with 2, it's just 1/2. I need to replace this with this. Does that make sense?
Yeah.
Okay. Yeah.
So what does the x do?
The x stays as an x. The x is just your variable. Yeah. All right. Example 6 just takes it to the next step. So here's a couple of things, right? On the left-hand side, on the right-hand side is my resulting composite functions. And then I've got choices for f of x and I've got choices for g of x. So you want to match the correct f of x and g of x to produce the given composite functions. So which one goes with which one to produce these on the end? I'm going to let you try it. See if you can figure it out. With the top one on the right-hand side. So we'll work our kind of right to left. What gives you e to the 3x squared plus 1? Which one?
F of x, 3x plus 1, and x squared.
So let's check it. So if I take this and I plug it in, I get e to the 3x squared plus 1, which is to the 3x squared plus 1. That one matches. Okay, so I should have done them all in the same color. Top, bottom, top. Okay, how about the middle one? F of x equals g to the x equals, or f of g of x equals e to the 6x. Which ones give you those? E to the 3x. And wait, which one? No.
Oh wait. No, I did that wrong.
The first here, right? So I would get this guy goes into here now. So e to the 3x raised to the second becomes e to the 6x, because when we raise a power to a power, we multiply. Okay, and then obviously process of elimination. Our bottom one, but we're going to check it anyways, would be these two. So I'm going to take the x squared plus 1. I'm plugging it into the x that's in the exponent. So e to the 3x squared plus 1, which gives you e to the 3x squared plus 3.
Why wouldn't the x for the final function
Oh,
be 6x?
This one? Oh, wait, which one?
Yeah, why wouldn't that one?
Because you're multiplying, when you raise a power to a power, you're multiplying. So it's 3 times x times 2. It's 3x times 2.
Oh, okay.
Does that make sense? Okay. All right, last one, example 7 says, given f of x equals x minus 2 and the graph of g of x, graph g of f of x and then graph f of g of x. So if my f of x is x minus 2, okay, and I want to find g of f of x, I'm going to take the f of x and I'm going to plug it in to whatever this function is, right? It's going to look like this. What does this do to a graph?
Moving right to.
Shifts it to the right too. So I'm literally going to take all the points that are on that blue line and I'm going to shift them to the right too. With me on that one? So we inputted, and by inputting, we're messing with what's in the parentheses, and by what's in the parentheses, we're causing a horizontal shift, okay? The second one says graph f of g of x. Well, g of x is that graph, right? So if I put g of x into f of x, it's g of x minus 2. This is not an equation you can find, right? But if I take a function and I subtract 2 from it outside the function, what does it do to the graph?
Move it down.
Moves it down 2. So I'm going to take each of the points and I'm shifting it down 2 places. Actually, wait, sorry. This is not there. I plotted the wrong point. This guy is not there. I'm just moving the original ones down 2. I accidentally moved one of the other ones. Questions on anything composite function related? Okay, so again, like in AP style questions, they love to like combine an equation with a chart, with a graph, and then or multiple graphs or multiple charts, whatever it is, and you've got to be able to make them composite functions. Yeah, yeah.